Alright folks, welcome to the third video of this series where we're dealing with simultaneous equations. This video and the video to come after, the fourth video, is of particular interest because in these two videos we will be taking a little detour, a little deviation away from some of the popular methods, from one of the popular methods, that is taught in textbooks and in schools and by teachers all over. So, listen up, pay attention, we go in. So in this instance, we have another pair of simultaneous equations. We have 4x minus 5y is equal to minus 14, that's equation 1. We have 3x plus 2y is equal to 1, that's equation 2. So unlike the first set of simultaneous equations which we dealt with in videos 1 and 2, in this case we do not have a unitary coefficient. So when you look at everything here, there is no plus or minus x, there is no plus or minus y. We have 4x and we have 3x here, we have minus 5y and we have 2y here. So what do? We manipulate the equations. We change the appearance of the equation without changing the value. Let me talk about that a little bit again. When you have an equation, so long as you do the same thing on the left side that you do on the right side, then the value of the equation remains. So for example, if I say that x is equal to 5 and I multiply that equation by 2, I'll get 2x is equal to 10. Saying that x is equal to 5 is exactly the same thing as saying 2x is equal to 10. The only thing that changes is the appearance, the form, not the content, not the value. Alright? Keep that in mind. So using that idea now, we're going to interfere with both of these equations, alright, so that we could move forward with the question. Now, in this case, we're going to pivot, know the language, we're pivoting on the x variable, which is simply to say we're dealing with the x variable first. That's all we mean. Good? So, if we have 4x here and we have 3x here, what we want to do is manipulate these two equations such that we get the same coefficient of x. Well, the coefficient doesn't have to be exactly the same, and you will see that in video 4. What needs to be the same is the magnitude of the coefficient, not necessarily the value. So in this case, we have 12x here and 12x here. It could quite easily have been 12x here and minus 12x here. The procedure will be the same, but don't worry, we come to that in video 4. So for now, let us stick where we are. We have 12x here and we have 12x here. Alright, so how do we get the 12? Where does 12 come from? We're just talking and all of a sudden 12. Remember, we talk about the lowest common multiple, or the LCM. Right? That is the simplest way to manipulate these two equations without changing the value of either of them. That will allow both of them to appear in a form where we could interact them in a productive manner to solve the values, to get the values of x and y. So, we know that the LCM of 4 and 3 is 12. Now, all of this, most people tend to get, right? Here is where the things are to get thingy. Alright? So, if we want to get 12x here, we multiply the whole equation by 3. In other words, we multiply the whole of the left side by 3 and we multiply the whole of the right side by 3. So, 3 multiplied by all of this, 4x by 3 is 12x, 4x by minus 5y, note the inclusion of the sign, is equal to, 3x by minus 5y will give you minus 15y. Good? So, let me run that again. Equation 1 by 3, 4x by 3 is 12x, minus 5 by 3 is minus 15y, and of course, minus 14 by 3 is minus 42. Good? So, we have that. And then in equation 2 now, because we're trying to get 12x here, because we're dealing with the x variable and we want the magnitude of the coefficients to be the same, then we have to multiply equation 2 by 4. So that 3x plus 2y by 4, that's the left side. 3x by 4 is 12x, 2y by 4 is 8y. And on the right side, 1 by 4 is will always be 4. Good? So we have equations 3 and equations 4 now. Having gotten to this point, where we now have equations 3 and 4, we now make 12x the subject of the formula in both of these equations. So from equation 3, instead of doing, in fact no, let me just finish explaining this and we'll go back. So from equation 3, we can see that 12x is equal to minus 42 plus 15y. In other words, you take the minus 15y on this side and you bring it across here to give you plus 15y. So that from equation 3, 12x is equal to 15y minus 42. In equation 4, your 12x will be equal to 4 minus 8y. You take the plus 8y and you bring it across. So 12x is equal to 4 minus 8y. Now, what I would call the classical method, the elimination method, up to this point, we on par with them. What they would do up to here, is that we would have an elimination where we take away one equation from the next one, or where we add one equation to the other one. In this series of videos, we're not dealing with that method, right? We're introducing a different method, a variation, a variant, so to speak, which I honestly believe will be a little more straightforward, because in the regular elimination, if there's a lot of room in there for people to trip up with the signs, the plus and the minus. Sometimes you're not sure whether to add the equations or whether to subtract the equations. And sometimes, even when you get to that point, in the execution, you could run afoul of some of the laws of the signs. Good? So we have a slightly different method here, where instead of trying to eliminate 12x by addition or subtraction of equations 3 and 4, what we do is we could say now that we're pivoting on the 12x, right? We're not trying to find x, we're trying to pivot on 12x. So we say that 12x is equal to 15y minus 42, and 12x is equal to 4 minus 8y. Now that we have that, 12x will always be 12x, whether it's 15y minus 42 or 4 minus 8y. So we could say now, it follows logically, that if 12x is equal to this and 12x is equal to that, then naturally this is equal to that. In other words, 15y minus 42 is equal to 4 minus 8y. Alright? And then you follow your regular laws of algebra here. You have your minus 8y here, you bring it on the left side, so you have 15y plus 8y, and then you have your minus 42 on this side, which you would carry across here to get plus 42. So you have 15y plus 8y is equal to 4 plus 42. Now, 15y plus 8y will always give you 23y, and 4 plus 42 will always give you 46. Which is to say then that 23y is equal to 46, and y is equal to 46 divided by 23, which will always give you 2. So y is equal to 2. And now, having found y is equal to 2, you substitute it back into equation 2. Just as we said in videos 1 and 2, at this point you have the luxury of substituting back into either of equations 1 or 2. In this case, if you want to be difficult to yourself, you could even substitute it back into equation 3 or 4. It really doesn't matter. Alright? But as is usually the case in a lot of things in life, whenever you have the opportunity to simplify things, you do so. So in this case, what you do is look for the simplest equation and use that in your substitution to find the value of the remaining variable. So in this case, the simplest equation looking like equation 2, right? So you substitute y is equal to 2 into equation 2. So you'll get 3x plus 2 by the value of y, which is 2. 3x plus 2 by 2, 3x plus 4 is equal to 1. That's what we have here. So 3x will be equal to 1 minus 4, which is equal to minus 3. Of course, you would have taken the plus 4 on this side and carried it across here to get minus 4. So 1 minus 4 is minus 3. 3x is equal to minus 3. x is equal to minus 3 divided by 3. That's what the slash there is for. Minus 3 over 3, which is equal to minus 1. So therefore, your x is equal to minus 1 and your y is equal to 2. And that, ladies and gentlemen, is the solution for this equation. Just to recap quickly, right? We found at the beginning that we didn't have a unitary coefficient anywhere inside here where the variables are. So we pivot on the x variable, which is to say, having 4x here and 3x here, we're looking at 12x as LCM. So we have to do something to each of these two equations to get 12x. So we multiply equation 1 by 3, boom. We multiply equation 2 by 4, boom, boom. Alright? So 12. So from equation 3, we make 12x the subject of the formula, not x, 12x. 12x is equal to 50y minus 42. And from equation 4, we do the same thing. 12x is equal to 4 minus 8y. 12x is equal to 12x. So 15y minus 42 will be equal to 4 minus 8y here. And then we bring all the like terms on one side. We bring all the y's on one side. So in other words, now we have an equation in one variable, which we're going to find. So 15y plus 8y, we bring the minus y across here. 15y plus 8y is equal to 4 plus 42. 23y is equal to 46. Y is equal to 46 divided by 23, which is equal to 2. And then when you get y is equal to 2, you substitute it back into the simplest equation of these four, which in this case is equation 2. And when you substitute, you end up with 3x plus 4 is equal to 1, 3x is equal to minus 3, x is equal to minus 3 by 3, x is equal to minus 1, y is equal to 2. So in the following video, video 4, we're going to pivot on the y variable. Right? We're going to do the same thing that we did to x here. We're going to do that to y. And you will see where, in that case, the magnitude of the coefficient is what we're looking at, much more than the sign per se. Alright? But if you're not sure, stay tuned, look out for it. Video 4 coming up next.